All right, surprise, surprise. We did our hypothesis test. Now guess what we get to do? You guessed it, confidence interval. Woohoo, right? All right, so a simple random sample of size N1. Remember, these are independent. So I have a random sample of N1, population unknown with this mean unknown standard deviation, right? So everything goes with 1. And then also, a sample of N2, mean of 2, standard deviation of 2. 2 populations are normally distributed, or the sample sizes are large enough to handle it. Each one, they are independent. Do you feel like this is a broken record? I just keep saying the same things over and over because I want to make sure you recognize that and you get that in your head. So we have these 2 formulas. Now they're a deal. So buckle up, because everything that we have is based on 2 pieces of information. So the mean, sample mean of the first one minus the sample mean of the second one, minus the critical value that we have times the first standard deviation squared over the number in the the number in the sample, the second standard deviation squared over that number in the sample. That's the lower bound. You have to have info for each one. So what do you think is going to happen with the upper bound? Yeah, literally the exact same thing, except it's a plus sign. So my first one minus my second one plus the critical value in the square root of the standard deviation squared over the sample, and then the second standard deviation squared over that sample amount. The upper bound and the lower bound, where the critical value is computed with your degrees of freedom independent, right? Right. Using, using the smaller of the 2. That's important. So these are independent values. These are independent values. However, if they are different, sometimes we have the same, right? Like we just had the exact same that we did previously. But if it is a discrepancy and you were to find this critical value, we'll be using StatCrunch, but it's just good to know, then you always go with the smaller sample size. All right, that's the one you go with. Just a rule of thumb to go with. All right, we are going to let StatCrunch do the heavy lifting for us because, well, you know, it's an amazing tool, so why not use it? I'm going to scoot this up, and we're going to rock the socks off this thing. The big thing is different is a group. 2 is a group, right? What's the lower bound to the upper bound that we're going with? Let's check out old Gallup and see what their polls got going for us. A Gallup poll of 513 national adults aged 18 or older who consider themselves to be a Republican asked, of every tax dollar that goes to the federal government in D.C., how many cents of each dollar would you say are wasted? The mean amount is 54 cents with a standard deviation of 29 cents. The exact same question, let's go pink. The exact same question was asked of 513 Democrats. Now here's the deal. This one happens to be the same. They both asked 513, but you don't have to. You don't have to. All right, this happens to be the example the book puts together, but the reason why we have this caveat right here is because these could be different. Okay, sorry, I squirreled away on you there rather than just finishing my thought, but you get it. So 513 Democrats, the mean is 41 cents and a standard deviation of 2.6 cents. We are charged with constructing a 95% confidence where the mean of Republican minus the mean of the Democrats, and then we want to interpret that. Now, do we have like a piece of data here? No, we don't have individual data points. This is where we go with the summary. Ooh, I didn't write it on the last one, so we'll write it right here. We didn't write out our stat crunch steps, but you know that it's going to be in the same place. Stat crunch will be stat, T-stat, because this is a mean, and because this is 2, we're going to the 2 sample. Now then from there you have to decide, are you going to do with data because that's what you have, or are you going to have with summary? Luckily in this section we're doing both, right? We did with data on the previous one, even though I showed you what the summary looked like. And then here you're really going to get to see what the summary is all about because we're going there right now. So let's pull it off. So stat, this is still a mean. So we're doing T-stats. They're independent. And we have the summary. So do you see where all of that goes? So you can see that? All right, I'm going to scoot this up and bring this up to it also. For our first sample, we're going to do the Republican information first, and then we're going to do the Democrat information for sample 2. So for sample 1, we have the mean of Republicans is 54 cents. So we're going to put 54 in there. The standard deviation is 2.9, and the sample size is 513. The mean for the Democrat is 41 cents. So 41. The standard deviation is 2.6 cents. And there were 513 also. All right. We're not doing a hypothesis test. We're doing the confidence interval, and it is at 95%. So that's awesome. And then let's compute. So here we have our upper limit and our lower limit. So let's write those out. We have our, I'm going to do lower first and then upper because for me that makes sense. Small to big, right? It's kind of in order. Lower and upper. 12.663 and 13.337. That is what we're looking at. All right, I'm going to scoot this over. The data we are discussing in these limits are cents, right? That's the data that we have. We're talking about cents here. So this is from 12.6 cents to 13.3 cents. So what we are saying is that we are, I don't know, let's just go black. We are 95% confident Republicans believe the mean amount of each dollar, collected by the federal government, that is wasted is between, I'm going to shore this up a little bit so I don't have to write that much, 12.7 cents and 13.3 cents higher than the mean amount Democrats believe is wasted. Okay, so look at what happened there. This is positive. This is positive, and this says Republicans minus Democrats is right there, right? So if these values are positive, that means the Republican number is bigger than the Democrat number. So with these being positive in terms of these cents, Just so you can have that. Just think, side note, this is the last video, so you're not going to have to endure my handwriting anymore. Oh, that should make you so happy. Oh, goodness sakes. Okay, so we are 95% confident that Republicans believe the mean amount of each dollar collected by the federal government that is wasted is between 27.3 and 13.3 higher. That doesn't mean that's just the Republicans. That's the difference. Do you see where this is going at? And because these are positive, then this is a bigger number, and that's why the word higher is used than what the Democrats believe in this Gallup poll. All right? That's what we want to know. So we're constructing a confidence interval of Republicans minus Democrats and then interpreting that. If this were negative, then what we would say is lower, because that means that this is a smaller amount than this one. That's what makes it negative. Do you see where that came from? Okay. That's where these words come in, and it's statistics. So all of the words are going to make an impact for you. That makes a big deal when I'm looking at these different words and what they all represent. All right? You guys did it. Oh, right? Very last video. Oh my gosh, I feel like getting up and dancing a jig or something, right? You guys have to be just as stoked as I am. Way to go. You are awesome. Now go rock the socks off of this final exam, and you have got this. Way to stick with it and way to power through. You guys are just so amazing. I don't even have words for it. Well done.